brings up these images, right? Brilliant, maybe a bit eccentric.
Definitely eccentric, yeah.
And often standing apart from the standard story of science. He gets credit for so many inventions that basically built our electric world. But then there are these grander ideas.
Like wireless power for everyone.
Exactly. Or radical new energy sources. And they're still talked about with this mix of, like, awe and maybe some skepticism.
It's a truly fascinating space, isn't it? Where you've got this undeniable genius intense speculation. You see discussions all over the place. From how his ideas on consciousness might be, quote, validated by modern tech like EEG and AI, to these claims that his biggest discoveries were actively suppressed, maybe by governments or big industry figures.
So today, that's exactly what we're doing. A deep dive into these enduring and sometimes pretty controversial theories of Nikola Tesla.
Sounds good.
We've got a bunch of sources. There's a really lively Reddit thread from someone who's gone deep into his work.
Sounds interesting.
And also some solid scientific articles covering the history of electromagnetism, the real physics of wireless power, the groundwork.
Okay.
So our mission here is to unpack these ideas for you, see where modern science actually stands, and maybe understand why Tesla's still such a compelling, maybe even polarizing figure to think about.
Let's do it.
So let's unpack this. Tesla's enduring visions, from consciousness to AI. Okay, so our deep dive kicks off with this powerful idea from a Reddit user, someone who's really found a new passion for Tesla's work. And they argue that with today's tech things like EEG scans, electromagnetic field meters, AI analysis, we might finally be able to figure out what Tesla's really onto.
Kind of validating his theories.
Yeah, potentially validating his ideas about energy, consciousness, frequency, that kind of stuff.
Well, it's true that Tesla had some incredibly expansive thoughts way beyond just electrical engineering.
Right.
He really dug into the relationship between technology and the human mind, like deeply.
How so?
He even suggested consciousness isn't just, a byproduct of brain chemistry, but maybe a complex thing that technology could influence, maybe even enhance.
Enhance consciousness.
That was the idea. He believed the mind might operate in a frequency spectrum, kind of like radio waves, suggesting a connection to what he called conscious universal energy fields.
Wow, okay. That's where it gets really interesting to think about. Because that idea, it sort of resonates with ancient wisdom, doesn't it? Like Advaita Vedanta, suggesting reality is all just interconnected energy and intelligence.
It does have that echo. And Tesla famously said, if you want to find the secrets of the universe, think in terms of energy, frequency, and vibration.
And this Reddit user, get this, they're actually running an experiment based on Tesla, involving fasting, sleep deprivation, tracking with EEG.
Whoa, really? To see if altered states boost creativity?
Exactly. Directly inspired by Tesla.
Yeah.
Pretty wild.
And, this isn't just abstract philosophy either. Our sources point to a growing belief that AI could actually breathe new life into some of Tesla's overlooked discoveries.
Like how?
Well, imagine AI optimizing energy grids globally, or predicting renewable energy needs way better than we can now.
Okay.
Or even using quantum computing to tackle problems Tesla just didn't have the tools for back in the 19th century.
Right, the tech limitations were huge then.
Some even speculate he might have tried to tackle climate change with geoengineering, or push some of those fringe electromagnetic therapies into the mainstream if he had today's tools.
It really makes you consider the potential, doesn't it? If those bigger, more philosophical ideas were chased with modern tech, the allure of wireless power and its controversies. Okay, let's talk about one of his most captivating visions, free energy and global wireless power.
Oh, yes, Wardenclyffe Tower.
Exactly, that giant tower on Long Island. The whole point was transmitting energy without wires, right, across huge distances.
Absolutely, and our sources really highlight a key difference in philosophy here. Tesla saw energy as something natural, abundant, something to be harnessed for everyone.
Not just sold, like Edison's model.
Precisely. And that vision, that difference, often fuels these narratives about suppression.
Like what?
Well, there are claims that when he died, the U.S. government specifically mentioning figures like J.G. Trump, actually.
Wait, that Trump?
His uncle, yes. The claim is they seized his files, maybe to control the tech or hide it. Fears it could make war impossible or provide, as one source put it, too many nice things. Almost like Star Trek tech landing too soon.
Huh. And some even claim Wardenclyffe burning down wasn't an accident.
That's another part of the narrative, yeah. That it was purposefully destroyed. Hard to prove, of course, but the story persists.
And then there's the legendary Teleforce project.
The death ray. or the peace beam, depending on who you ask.
Right. Tesla saw it as this particle beam weapon, powerful enough to destroy thousands of airplanes from hundreds of miles away.
Yeah.
His idea was it would make war impossible.
An end to war through ultimate deterrence.
He pitched it around, didn't he, to different governments, even reportedly struck a deal with the Soviets for a test.
Well, the historical accounts get a bit murky here. Some sources say he never actually built a working prototype, and that people like J.G. Trump looked at the plans and dismissed it as impractical.
But others disagree.
Yeah, strikingly so. Others in our sources flat out assert that Teleforce tech is in common use today.
Seriously.
Yeah.
In what form?
They point to things like colloidal microthrusters for satellites, or ion beam lithography that can supposedly slice through any known material.
Wow. So a huge difference of opinion there. Was it genius, delusion, or a reality that just got hidden and repurposed?
Exactly. It's one of those enduring Tesla mysteries.
From early discoveries to Maxwell's grand theory.
Okay, so to really get a handle on these debates, especially around wireless power, we probably need to ground ourselves in the science itself, electromagnetism.
Absolutely fundamental. It's one of the four basic forces, and the one we can really manipulate on a human scale, unlike gravity or the nuclear forces.
Its history is long, right? Goes way back.
Oh yeah, deep history. You start with ancient Greeks like Thales noticing static electricity with amber, or the pull of lodestone magnets.
Just observing things.
Mostly qualitative, yeah. Later, you get Peter Peregrinus defining magnetic poles, William Gilbert trying to separate electric and magnetic effects, still mostly describing what happens.
Then came the scientific revolution. Things got more mathematical.
Exactly. Quantitative measurement became key. Isaac Newton's calculus gave scientists the tools they needed to describe forces precisely.
And we saw breakthroughs like the Leyden jar.
Right, for storing charge.
Right.
And Alessandro Volta's battery giving it continuous current for the first time. Plus, Benjamin Franklin figuring out positive and negative charges. These were huge steps, building blocks.
So how did electricity and magnetism start to come together?
The big connection came with Hans Christian Ørsted. Almost by accident, he saw that an electric current creates a magnetic force.
Ah, the compass needle moving.
That's the one. Then André-Marie Ampère jumped on that, measured it carefully, gave us the right-hand rule to describe the direction. But the really massive leap, maybe the most relevant for Tesla, came from Michael Faraday.
Faraday, he didn't have much formal schooling, right?
Very little. But he had this incredible intuition. He visualized these lines of force filling space. And crucially, he showed that changing magnetic fields create electric currents, electromagnetic induction.
Why was the changing part so important?
Because it meant these effects weren't instantaneous. They had to travel, to propagate at a finite speed. Faraday realized that change, dynamics, was the key, not just static forces. That unlocks so much.
So Faraday sets up this idea of propagating fields. Then what? All these pieces were lying around.
Exactly. They laid the groundwork for James Clerk Maxwell in 1873.
And what did Maxwell do?
He took all these discoveries, Ørsted's, Ampere's, Faraday's insights, and synthesized them into this beautiful, elegant set of equations. Maxwell's equations.
And they didn't just describe what was known.
That's the amazing part. They mathematically predicted the existence of electromagnetic waves traveling at the speed of light. And they proved that light itself is just one type of these waves.
Wow.
Then, just over a decade later, in 1886, Heinrich Hertz experimentally generated and detected the first radio waves, exactly as Maxwell predicted.
That's huge. The culmination of classical physics basically paving the way for, well, everything. Electric, telegraph, radio, motors.
The whole modern world, really, built on that foundation.
But physics didn't just stop with Maxwell and Hertz, did it? The 20th century arrived.
Oh no, things got even weirder. Albert Einstein comes along. His relativity theory showed that electricity and magnetism aren't really separate. They're two sides of the same coin, electromagnets, are just viewed differently depending on how you're moving. And then came quantum mechanics. The idea that light energy comes in discrete packets called photons. Einstein used that to explain the photoelectric effect, which led to wave-particle duality.
Where particles like electrons can act like waves, and waves like particles.
Exactly. Super counterintuitive stuff. You get Heisenberg's uncertainty principle, Bohr's complementarity, de Broglie's saying all matter has wave properties. It completely changed how we see reality at the tiny scales.
So how does this all fit together? Maxwell, Einstein, quantum mechanics?
Ultimately, it led to quantum electrodynamics, QED, developed in the late 1940s by Feynman, Schwinger, Tominaga. QED describes how light and matter interact at the most fundamental level exchanging virtual photons.
That's complicated.
It is. But here's the crucial bit. For large systems with lots of photons, QED's complex calculations actually simplify right back down to Maxwell's equations.
Okay. So Maxwell's equations still work for the big picture.
They perfectly describe the average behavior, the macroscopic effects we see and use every day. QED is the deeper quantum reality underneath, reconciling Tesla's claims with modern electromagnetism.
Okay, so we have this solid foundation of electromagnetism from Maxwell up through QED. Now, the big question, how do Tesla's most radical claims, especially about global wireless power, actually square with this established science?
Right. This is where we hit a major point of contention, looking at our sources. Tesla was insistent that his wireless power wasn't about Hertzian radiation.
Meaning standard radio waves like Wi-Fi or broadcast signal?
Exactly. The kind Maxwell predicted and Hertz demonstrated, which radiate energy outwards through space. Tesla talked instead about waves of current energy traveling through the Earth itself.
Okay, but how does mainstream science see that?
Well, the consensus view, detailed in our sources, is that you simply can't separate the electromagnetic field from the charges and currents that create it. Any transfer of energy, even if you call it current energy, in the Earth, is ultimately mediated by the electromagnetic field. And the part of the field that carries energy over distance is the radiating Hertzian part. It's all governed by Maxwell's equations.
So what about these non-Hertzian or scalar waves people sometimes associate with Tesla? Is there anything like that in physics?
The closest established concept is what's called the near field. That's the region very close to a transmitter antenna.
Okay.
In the near field, the electric and magnetic parts of the wave are kind of out of sync, and energy mostly sloshes back and forth between the antenna and the immediate space. It's called reactive power. Think of it like borrowing energy for a moment and then giving it back.
So it doesn't really go anywhere.
Not efficiently, no. But here's the key point. Any real power that actually does get transferred out of that near field to do useful work far away is still carried by the standard radiating Hertzian component of the wave. Claims of fundamentally different types of waves, like scalar or longitudinal waves carrying power, just aren't supported by the known laws of electromagnetism. Radiation travels transversely.
Got it. Now, Tesla thought he could minimize wasteful radiation by displacing a lot of charge, but doing it close to the ground, right?
Yes, he believed he can pump charge into the Earth at a low height.
But our sources say that reasoning was flawed. Why?
That's right. The core issue, according to the physics, is that the reach of those Earth currents doesn't just depend on the amount of charge. It depends crucially on the dipole moment.
Dipole moment.
It's the charge multiplied by the distance over which it's separated or displaced. By keeping his transmitter electrode low, Tesla would actually have confined the fields, and therefore the useful Earth currents, closer to the transmitter. He seems to have misunderstood that the very far-field radiation he wanted to minimize was actually necessary to drive the long-distance Earth currents he wanted to use.
Huh. Kind of paradoxical. He was trying to suppress the very thing he needed.
It appears that way based on standard EM theory, yes.
And what about using the whole Earth ionosphere system as a giant resonant cavity, like ringing a bell to send power everywhere?
It's a grand idea. And the cavity does exist. We can measure natural resonances in it, the Schumann resonances.
What?
But our sources are clear that cavity has a really, really low Q factor.
Q factor, meaning?
Think of Q as quality. A high Q bell rings for a long time. It holds energy well. A low Q bell, like one made of lead, just thuds. It loses energy very quickly. The Earth ionosphere cavity is very low Q. It's extremely lossy.
So too much energy would just leak out or be absorbed.
Exactly. Hopelessly inefficient for transferring power globally that way. It makes that specific vision of Tesla's seem impractical based on the physics.
It really highlights the gap, doesn't it, between a brilliant visionary idea and the tough demands of scientific proof and engineering reality.
It does.
And it seems like some critics argue that Tesla, maybe later in his career, kind of bypassed the normal scientific process, appealing more to the public or patents, instead of addressing criticisms from other scientists.
That criticism does appear in some of our sources, yes. The scientific method thrives on that open critique, peer review, experimental validation. It's designed to be self-correcting.
Right.
And when serious questions were raised about the feasibility of his wireless power schemes, based on established physics like Maxwell's equations, some accounts suggest Tesla didn't really engage with those criticisms directly in the scientific literature. He didn't try to refine his theory or experimentally disprove the critiques in a way that satisfied the scientific community.
So maybe a missed opportunity to really hash it out scientifically.
Perhaps. It's seen by some as leaving this legacy of, well, undeniable genius in many areas, but also these unresolved scientific questions that keep sparking debate, even today.
Outro.
Wow, okay, this deep dive into Nikola Tesla's theories.
It's been quite a journey, hasn't it?
That really has a complex figure.
We've seen how his really profound insights maybe into consciousness, energy, frequency, how they kind of resonate with really cutting-edge fields now, like AI and quantum physics.
There are definitely echoes.
But then his specific big proposals, especially for global wireless power, they often seem to clash pretty hard with the established science of electromagnetism that we've walked through.
It's a good reminder, isn't it? Tesla was absolutely a brilliant inventor. His work on AC, electric motor, that's the backbone of our world. Indisputable.
Totally.
But the path of scientific progress, it's built on that rigorous testing, that open critique, constantly refining our understanding. It's a collective effort.
So for you, listening to this, the key takeaway maybe isn't about, diminishing Tesla's genius at all, but more about appreciating the full, complex picture.
Exactly. Understanding the foundational physics that runs the universe as far as we know it.
And using that knowledge to look critically at historical claims, but also at future innovations, too.
Right. Which leads to a final thought to leave you with.
Okay.
Think about this. What surprising scientific discoveries might be just around the corner now. Discoveries that could challenge our current understanding, just like Tesla challenged the understanding of his time.
Good question.
And maybe more importantly, how will you, as someone who's informed and curious, approach those new, potentially disruptive ideas? How do you balance having an open mind with that essential critical inquiry?